Uh, so the LLM does what is known as it imputes. What does impute mean? Traditional functions that we've written in our past lives, a function takes a set of arguments and it produces an output. A function one could take in an argument, could take in three arguments, A, B, and C, and produces an output. Another function could take another set of arguments, it produces a different output. So functions are written by humans, and you write programs, you write complex stacks. That's what a function does. An LLM does the reverse of that. It infers, and LLM can do a lot of things, but the capability that we are trying to leverage is, given an output, infer the function that maps to that output. Right? So the reverse of that, so you feed it an output, and once you feed the output to it, using this key technology called a model, it is able to then say, if you were to use this function with these arguments, this output would be found. Right? So it does a reverse mapping, and in the degenerate case, which is computationally inefficient, this model could be nothing but a series of all possible outputs and all possible functions. That would be the answer. Clearly, that's not possible. There's not enough compute power out there that you can create such a big lookup table. This is where the how do you train the model, how do you build the model, all of those things start coming in. Right? So how do we build the model? So now we are peeling the layers. We are now getting to the part is, how does one go about building the model? Right? So again, saying the same thing, the LLM will take in the English phrase, and it has the right model alongside with it. As soon as it has the right model, it will output the SQL query that corresponds to the statement that was given over there. Right? So how do we build a model? That whole process is called training. And how does Selector build a network LLM model is along these layers. You first start with a base model, right? This base model and we use a public domain model because this model is trained on English. It figures out all nuances of English. Or it also does things like translation. For example, if you want to go from one language to a different language, the public models are trained on it. Anything related to English, this model understands. This model, like Meta publishes a Llama 3 model. Customers sometimes might have their own general purpose English model. It could be anything. Selector's IP is not in this part of the model. Right? So once we have this model, then we bring in the first fine-tuning aspect to it. Just as background, fine-tuning is the process by which you have a model and you make it more intelligent by giving it more examples. So this is the first step that we do. We teach this model how to understand SQL and the nuances of the SQL implementation inside Selector. So you teach that. You give it enough examples of some outputs and some SQL, and it's able to learn all of that. Note over here, this is customer independent. This part of the fine-tuning has got nothing to do with our customers, because all we are teaching the model how Selector thinks network data needs to be mapped. Right? All of that is happening over here. And this training happens in our cloud. Because this doesn't depend on customer data. We train this model and we publish this model periodically to our deployments. Then the third aspect is, we take in a customer environment, we use the customer data to further fine-tune the model. For example, in the multi-cloud networking, they have tenants. Their tenant might be a company called Splunk or what have you. Those keywords have to be taught to the model. In a different environment where they might have sites in Denver or Ashburn, they need to be taught that, yes, these are my entities in my system. Right? So those entities are very customer specific. So there is an aspect of the model training that happens on premise inside the customer. Right? So if I were to look at our different customers A, B, and customer C, the core of the model and the selector part is common everywhere. Right? Customers A, customers B, customers C, the core models look the same. However, the final fine-tuning that happens in the context of a customer. Right? So this happens on customer premises because the customer's data cannot leave their cloud or their infrastructure. So then this completes the whole picture now. If I were to look at our stack, we have the model at a given customer. the model has been tuned, has been fine-tuned, and that model now needs to run in an execution environment. So we built a execution environment, and we just call it LLM OS. This LLM OS is the runtime environment for the model. The translator layer interacts with this thing, and it sends over English sentences, and queries come back to it. All of that interaction happens at the top. Once this happens, now you can see show me errors in Ashburn. That phrase goes to the LLM OS. It looks at the corresponding model. It imputes. It comes back with the right SQL query, and that SQL query gets forwarded to storage. There's another aspect of the LLM which I will not go into today, that once the data comes back, sometimes you might want to summarize that data, because it might not be always summarizable as a chart or a line plot. You might want to give an English summary to that. That's a secondary workflow, but it'll work along the same lines. You can think of it. It will figure out what summary should be built. It's more of an English to English translation at that layer.
Can I jump in for just a second? This is Remy. Can you clarify how long, you mentioned the training of the model on customer data. So presumably you first have to gather the data. So there's a period of time in which you're ingesting information, and then you're doing model training on the data. So can you give us a feel for how long that is between data collection, training of the model to usability?
Right. So yeah, this slide will explain that. These are different deployments. Customer A runs in, say, their cloud. Customer B runs in their cloud, and then there's Selector Cloud running in our cloud. Right. So the bulk of the model and the bulk of the fine-tuning happens in Selector Cloud. That happens periodically, and we keep doing that, and we publish a model to the rest of the world for our customers, maybe every week or every other week. We have a cadence for that. And then that model doesn't have to be retrained again in customer premises. Only the thin layer has to be fine-tuned all over again. So it takes it doesn't take a whole lot of time, maybe a couple of hours, because it's not rejigging the entire environment. Yeah.
So that thin layer that you're talking about, I guess, is as you work with your customer and you say, okay, I'm going to use SNMP or I'm going to use syslogs. Your team is part of the not professional service, but as part of the
solution building.
The solution, you're creating these tables based on the requirements of the user. So you know what the tables are, you know what the fields are. The customer doesn't have to worry about that because that's what the internal team is building.
Yes.
Okay. And so and then it's those table definitions that are making up that fine-tuning outer layer.
Yes. Those tables form the source for the fine-tuning outer layer. So there is an interaction between the local trainer over there, which will read these tables and just feed and hydrate that model with more and more stuff from this concept.
So the first step in the process, which is how do I take this query phrase and know which tables I'm going to query? You already know the finite set of tables that exist.
Yes.
And then there's some bit of, LLM wizardry that does some kind of mapping, I guess.
Yes. So suppose, just to play that out, suppose we did not do any training on customer A. We didn't do any training, right? Then if you were to say, show me port errors, the base model and the selector LLM will know port errors actually is trying to interrogate the interface errors table. It will be able to render that, but the whole data will come through. What the customer-specific training allows you to do is show me errors in Ashburn. The Ashburn is maybe a very common word, but say it was something very, very specific. That entity would not be recognized by the core model, right? That entity would be present in a table locally over here. That needs to be taught to the model that if you see this set of words, this word actually, you need to learn to say this is a site or a circuit or an IP address, whatever that is.
So if you have a CMDB then with all my devices in it and sites in it, then you know the full set of sites.
Yes.
So if you see that token, oh, this is a site, and it maps to a field that looks and feels like the word site.
Right. Yes. Yes.
So one other point, Michael Winston, I'd like to clarify, make sure I understand. Selector AI, the platform, doesn't need direct access to any of the infrastructure itself. It's using the information we feed it to train the LLM so that we can get this information out and reduce MTTR.
It needs access to the data. right? So
But it doesn't need access to the device, right? What I'm trying to figure out is there's no network discovery engine that goes out and finds all my routers and switches and firewalls and all of that and then makes sense of it. I feed it data, say, like you mentioned earlier, from Netbox or CMDB or from Splunk or from these things. And based on data models that you've already used, it can produce this table information that I can query.
No, the ingest layer has a discovery component to it as well. If you say that I need you to discover, or I need you to connect to Netbox, I need you to connect here. So you can say, I don't have a Netbox, I need you to crawl and discover my devices. At that point, there is a module that gets deployed inside the ingest layer, which would then go do device discovery, figure out the device inventory, figure out different things, and populate internal tables to be able to talk to them.
Can I do it without discovery?
Pardon me?
If I just feed it data?
You can give it data as well. You can say that here is my list of devices. So you can do all of that as well.
The reason I ask that is because a lot of the other platforms we've looked at and a lot of the other management platforms require direct access to every device in your network. And then when you run into challenges with firewalls and network address translation and other hurdles or obstacles in the environment in discovering everything,
Yes.
it makes an implementation much more challenging. But if you don't need direct access and I can feed the platform all the data I'm gathering from things that already have established access, it means my time for deployment goes from 9 months to a year to, well, just need to train the ETL, the transformation capability to be able to give me the data back so you can start training.
That's absolutely right, Michael. If you do not want to give access to your end devices, you can just give it the data and it'll do its job. Right? That's definitely the case. Yeah.
It's really interesting. Cool. Thank you.
So
Selector Cloud naturally enlists vector databases to minimize drift, hallucinations.
yes, we do use Chrome DB, which is a public domain software. That is what we use to store the models and do things like that.
Makes sense. Thanks.
Yeah. Any other questions? Did I answer your question on how the local training happens?
Yes, my question was on the total time frame. So I was interested, you have to have the data, right? You'd have to have the customer
Right.
data to actually train it. And so what I was trying to understand is, you answered half of it, right? Which is how long does it take to train once you
Right.
have data?
So
How
that's
much
Jeremy.
data do you need in order to be able to train effectively?
So as Jeremy pointed out, that data you would need no matter what. Suppose you were not doing LLMs at all. You need that data for annotating your queries to get business context. You would have ingested that metadata no matter what, right? So maybe the long pole is in getting access to that data.
Right.
That is generally driven by the environment where we deployed, what are the security policies. That is just human time, right? But once the data is connected, to scrape all the database, it's fairly fast. Once the data is available, the local training that the local LLM needs to be done, that training is half an hour or an hour, not more than that.